Question number 6. A diode is connected to a 220 volt AC in series with a capacitor as shown in figure. What is the voltage V across the capacitor? We know that a junction diode conducts during alternate half cycles of AC input supply. During a half cycle of conduction, the capacitor will charge itself to peak value of supply voltage. Therefore, voltage across the capacitor V equals to E naught equals to E RMS into root 2 equals to 220 into root 2 equals to 311.1 volt. Next, question number 7. The circuit shown in figure contains two diodes, each with a forward resistance of 50 ohm and with infinite backward resistance. If the battery voltage is 6 volt, find the current through the 100 ohm resistance. Since the diode D2 is reverse biased and it has finite backward resistance, no current will flow through diode D2. Only the diode D1 will allow current to flow in the circuit as it is forward biased. So total resistance of the circuit equals to 150 plus 100 plus forward resistance of diode D1, that is 50 ohm. So total resistance of the circuit equals to 150 plus 100 plus 50 equals to 300 ohm. Therefore, current in the circuit or through 100 ohm resistance I equals to E of 1R equals to 6 upon 300 equals to 0.02 ampere. Next, question number 8. Figure shows a junction diode connected to an external resistance of 100 ohm and a source of EMF of 3 volt. Assuming that the barrier potential developed in the junction diode is 0.7 volt, obtain the current in the circuit. Here EMF of the source equals to 3 volt. Barrier potential developed in the diode VD equals to 0.7 volt. Therefore, potential drop across external resistance V equals to E minus VD equals to 3 minus 0.7 equals to 2.3 volt. Hence, current in the circuit I equals to V upon R equals to 2.3 upon 100 equals to 2.3 into 10 to the power minus 2 ampere, that is 23 milliampere. Next, question number 9. A diode used in the circuit shown in figure has a constant voltage drop of 0.5 volt at all currents and a maximum power rating of 100 milliwatt. What should be the value of the resistance R connected in series with diode for obtaining maximum current? Here EMF of source equals to 1.5 volt. Voltage drop across diode VD equals to 0.1 volt. Maximum power rating of diode V equals to 100 milliwatt equals to 0.1 watt. Therefore, maximum current through the diode I equals to V upon VD equals to 0.1 upon 0.5 equals to 0.2 ampere. So, potential drop across resistance R V equals to E minus VD equals to 1.5 minus 0.5 equals to 1 volt. So, R equals to V upon I equals to 1.0 upon 0.2 equals to 5 ohm. Next, question number 10. Determine the currents I1, I2 and I3 for the network shown in figure 1. Use simplified model for the diodes. An inspection of the circuit shown in figure 1 shows that both the diodes D1 and D2 are forward biased. Using simplified model for the diodes, the circuit shown in figure 1 becomes the one shown in figure 2. The voltage across R2, that is 3.3 kilo ohm, is 0.7 volt. So I2 equals to 0.7 volt upon 3.3 kilo ohm equals to 0.212 milliampere. Applying Kirchhoff's voltage law to loop A, B, C, D, A, to the loop A, B, C, D, A, we have minus 0.7 minus 0.7 minus I1 R1 plus 20 equals to 0. So I1 equals to 20 minus 0.7 minus 0.7 upon R1 equals to 18.6 volt upon 5.6 kilo ohm. So I1 equals to 3.32 milliampere. Now I1 equals to I2 plus I3. So I3 equals to I1 minus I2 equals to 3.32 minus 0.212. So I3 equals to 3.108 milliampere.